All right, common questions number 4. We will review Yuri and I here to go through all these different topics. First thing, you just have to go back through your review book has all of these different features. You've got to be able to identify each feature, identify what put it there, and is it sorted or unsorted. So there's not a ton of sticky notes that really go with that, but www.ugg, knowing the sediment, describing the sediment, how is it sorted, but each thing. Wind will put things like sand dunes. Like in this right here, you see, what do you call it? A sand bar. So that's like a wave erosion thing, like a barrier island. So those are long, narrow islands that go parallel to the coast, and they're a really common thing to get asked about. So knowing all the different features, everything from a glacier, deltas, alluvial fans, you got to go through all of those. Spend some time studying those. Earth's orbit, what is it pointed to? So a couple of different ways you'll see questions on the angle of Polaris. Okay, the tilt of our Earth always points towards Polaris. So the North Pole always points towards Polaris. So the angle of Polaris is equal to the observer's latitude. So if we look at a diagram like this, that angle coming up off of the ground, off of the horizon, is your latitude. So if this angle is 20, you're at 20 degrees latitude. If this angle is 45, you're at 45 degrees latitude. Santa Claus would look straight up, 90 degrees in the sky, for seeing the North Star, Polaris. Yuri's got a note here. He's trying to pass notes. What's this say? 15 minutes for Earth science videos every Earth rotation. Oh, good job, Yuri. That's exactly what you should be doing. 15 minutes a day extra to make sure you're doing a good job. Sunlight. So if we look at how much sunlight, the strength of the sunlight changes. How much sunlight does each location get throughout the year? The equator, the amount of sunlight would look like this. The equator gets 12 hours of sunlight from January to the end of the year. Rome, New York. Let's go even more extreme, like the North Pole. In the wintertime, the North Pole would get 0 sunlight. Every location gets 12 in March. The North Pole will get 24 hours of sunlight. And then that graph wouldn't work for the North Pole. This is a location really north at the Arctic Circle. This would be the Arctic Circle. So this right here would be 66.5 degrees north. That's how the sun would work for that. June, hopefully I hit June 21st with 24. And then say a location like, we'll do Rome. So Rome's location in January gets less than 12. Everybody gets 12 in March, and then we get more than 12 in June, and then something like that. I didn't draw it perfect, but everybody gets the exact same amount on the equinoxes. When you average that out over the whole year, you get the exact same amount of sunlight throughout the whole year. Okay, but the equator always gets 12. Earth going around the sun and the Earth spinning. So for rotations, if 1 hour I wait, 15 degrees the Earth will rotate. Okay, so that's how fast the Earth spins, 15 degrees per hour. But the Earth going around the sun, this is a 360-degree circle, and it takes 365 days. So each day, the Earth is going about 1 degree per day to get all the way around. I'm not even drawing enough lines. About 1 degree per day to make a full 360-degree circle. Low pressure storm systems, you got to know that everything goes across the country from west to east. That's just looking up stuff in the ESRT. So looking up in your ESRT there. Which one of these things is correct? You got to remember, low is lousy. Okay. Low is lousy. I've got my diagram right here. Low is lousy. Cold fronts have precipitation right on the front. It's really heavy because there's all that rising air. So there's a lot of intense rain right on the front for a cold front. And then here is a warm front trying to push the cold air out of the way, and the warm air is ramping up over the cold air. So here's the warm front. Ahead of the warm front, you've got all this rain, but it's not as thick clouds, so it's not as intense storms. So ahead of a warm front, on a cold front, these would be like tornadoes, thunderstorms, intense type storms. And then right at the low pressure system. Rek Schweck. Oh, Yuri, you're falling down. Rek Schweck. I got Rek Schweck pulled aside here. So, a couple of things with mountains. Let's have that while we're looking at this diagram here. When you look at this diagram, a couple of things. The east coast is warmer than the west coast. That's because of your ocean currents. Okay, so in general, when we're looking at these different things, the east coast has warm ocean currents. So the east coast gets warm water coming up here. The California current is cool, and it cools off the west coast. So all things being equal, west coast is cooler than east coast. But then you've got different sides of the mountain. Okay, so when the air comes up the mountain, it's rising, expanding, cooling, condensation, and clouds. This is the cool side and the wet side. The back side of the mountain, like say over here, what did I do? The back side of the mountain is going to be warmer and drier. And then up on top of the mountain is also going to be cool. So like B is in the mountains, it's going to be a cooler place. B is also on the backside of, going down the mountains, so it would be getting dried out. Water changes temperature really slowly. The specific heat of water is high. So places like D are going to be much more moderate temperatures. It's going to change like this throughout the year. Places like C, which are not near the water, are going to change temperature a lot faster throughout the year. So less temperature change near the water, more temperature change away from the water. That's why the desert gets so cold at night. So same concept here. If C has an annual temperature of 55 degrees and F has 68 degrees, where is C? So the further north you go, it's going to get colder, and the further south you go, it's going to get warmer. Looking up metamorphic rocks from your ESRT, just remember any rock, you can look up the symbols. So they always ask a metamorphic rock question. You take your sedimentary rock symbol, say you're going to take sandstone. If it's this rock right here to start out with, like B would turn into, and I look down here, metamorphism of sandstone turns into quartzite. Okay, so every sedimentary rock is going to turn into a different metamorphic rock. A is this rock right here. So you have to look in your metamorphic rock chart. What does limestone turn into? Putting things in order, lowest on the bottom, oldest on top. If you look at these metamorphic lines, this must have came through afterwards because it metamorphosed, it changed everything else. Some review stuff there from other things. Polaris, which we already talked about. Windward, leeward, we already talked about. So a lot of similar questions. Tides, too high and too low every day. They're just over 12 hours apart. That's because the Earth spins. When we look at those tide diagrams, let's draw one real quick, I guess. If you've got the Earth right here and the moon is right here, you would have high tide and high tide wherever it lines up with the moon, and low tide, 90 degrees to the moon. Air masses, I wrote something down for that somewhere. So you got to remember, continental is sea. So that comes from the continent, it's dry. When air comes from the ocean, it's maritime, it's wet. Polar is cold, tropical is warm. I think that covers everything.